lecture on problems on control engineering. So here the problem is on determining the undamped natural frequency, that is omega n, and damping ratio for the given system response C of t equal to 1 plus 0.2 e power minus 60 minus 1.2 e power minus 10t. Upon giving this response C of t, we need to find what is omega n and what is zeta. Okay, so as a first step, we need to take the Laplace transform of the C of t. So it will become C of S. So one Laplace transform of 1 is 1 by S. Again, 0.2 is 0.2. E power minus 60 is 1 by S plus 60. So minus 1.2, 1 by S plus 10. So this is the Laplace transformation of the given system response C of t. So upon solving, we will get C of S. Upon taking LCM and solving, we will get S plus 60 multiplied by S plus 10 plus 0.2 S into S plus 10 minus 1.2 S into S plus 60. The whole divided by S into S plus 60 into S plus 10. So upon solving this, finally we will arrive into an answer of 600 by S into S plus 60 multiplied by S plus 10. You can also check by yourself. Other terms will get cancelled out. Only this constant term 600 will be available at the end. So we are having C of S. So next step. So we have so far got what is C of S. This is nothing but 1 by S. 600 divided by S plus 60. S plus 10. So, and then the given information in the question is input is unit step. That is given in the question. So for the input unit step, we will have R of S as 1 by S. That is Laplace transform of 1 is 1 by S. So now we have C of S and also we have R of S. We need to from the transfer function TF, that is equal to C of S by R of S. So we know C of S is nothing but 600 divided by S into S plus 60 into S plus 10. The whole divided by R of S is again 1 by S. So this both S terms will get cancelled out. So here the next step is transfer function, that is C of S by R of S now become 600 divided by S plus 60 multiplied by S plus 10. So if we multiply the denominator terms, it will become 600 divided by S square plus 70S plus 600. This is the final value of transfer function we have arrived for the given response C of t. Followed by this, we will compare this obtained transfer function 600 by S square plus 70S plus 600, the standard form of transfer function for a second order system, that is omega n square divided by S square plus 2 zeta omega ns plus omega n square. Okay. If we compare these two terms, we can equate the numerator term, that is omega n square as 600, whereby omega n will be equal to root of 600. So omega n value will be 24.49 radians per second. Similarly, the value of zeta can be obtained by equating these terms, 70 and 2 zeta omega n is. So 70 equal to 2 zeta omega n. So we already know the value of omega n, it is 24.49. If we substitute that, zeta will be 70 divided by 2 omega n. So 70 divided by 2 times 24.49. So the zeta value is 1.43. That is the value of zeta damping ratio. So we have obtained damping ratio zeta and undamped natural frequency omega n for the given C of t for the second order system. Given the unity feedback control system characterized by an open loop transfer function of g of s is equal to k by s into s plus 10, we need to determine the value of k for the given value of zeta as 0.5. In addition to that, we also need to obtain the value of MP, that is maximum peak overshoot, and TP is the peak time. Okay, for the given system, it is unity feedback only, one is a feedback. So in order to obtain these terms, we first have to obtain C of S by R of S, which is equal to G of S by 1 plus G of S into H of S. So upon given unity feedback system, we all know that H of S is equal to 1. That's the value of H of S for unity feedback system. Let me substitute the values available, k into s into s plus 10 divided by 1 plus k divided by s into s plus 10 multiplied by 1. H of s value is 1 here. So as a next step, if we solve the above equation, we will get k divided by s square plus 10s plus k. That is the final equation we are getting. So we need to find the value of k. For that, we will be equating this term to a general form of equation, s square plus 2 zeta omega ns plus omega n square. So by equating it, we all know that omega n square, that is k is equal to omega n square. And then next term, coefficient of s we will equate, that is 2 zeta omega n equal to 10. So the given value of zeta is nothing but 0.5. So from that, omega n is nothing but 10 by 2 into 0.5. So the answer is 10 radian per second. Omega n is 10 radian per second. So k value become 10 square. So k is nothing but 100. So out of 3 values, we have obtained the first value k. And addition to that, we also obtained omega n. From that only, we have calculated the value of k. So next we will find the other two parameters, that is MP and also TP. How to find MP? MP is nothing but e power minus zeta pi to 1 minus zeta square multiplied by 100. We'll substitute the terms accordingly. Zeta is minus 5. Zeta is 0.5. We'll substitute the values. Multiplied by 100. So it is 0.163 multiplied by 100. So percentage of MP is 16.3%. That is the maximum peak overshoot. Followed by this, we need to find what is peak time TP is equal to pi divided by omega d, where pi divided by omega d is expanded as omega n into root of 1 minus zeta square. So that pi will remain same. Omega n is 10. We have calculated. 1 minus 0.5 is given in the question. If we solve for that, we will get 0.363 seconds. This is the value of t. So we have obtained TP also. TP percentage of MP. So what asked? MP is 16.3 and then K is 100. For this given transfer function, zeta value, we have obtained the other parameters required.